Alright, video problem 12, electromagnetic radiation. Green light is between 5.36 times 10 to the 14th and 5.77 times 10 to the 14th hertz. Determine the range of wavelength for green light. So we're looking for wavelength, so it's going to be lambda. And we're going to have two different ones. We're going to have one for that value, one for that value. Let's label this A, let's label this B. So I'm going to say wavelength A is equal to question mark. The frequency at A is 5.36 times 10 to the 14th hertz. And then C, which is the speed of light, is always the same, 3 times 10 to the 8th meters per second. The only thing that may change is that unit right there. And so we have C is equal to lambda times nu, and this is for A. So C over nu is lambda. So I can say 3 times 10 to the 8th meters per second divided by the frequency, which is 5.36 times 10 to the 14th hertz, which is a per second. That's your lambda. So just plug that into your calculator. So I get a value of 5.60 times 10 to the negative 7th, and that's going to be units of meters. So there's that one. Let's look at B though. And we're going to do this one slightly different for B. It's wavelength of B. We're going to get this one in nanometers, just because sometimes people ask you to do that. And the frequency of B is 5.77 times 10 to the 14th hertz. C this time is 3 times 10 to the 17th nanometers per second. You know, it's the same value, just different units. So we're going to do the same exact calculation. So 3 times 10 to the 17th nanometers per second divided by the frequency, which is 5.77 times 10 to the 14th hertz, which is a per second. So now it's 3 times 10 to the 17th divided by 5.77 times 10 to the 14th. Negative value of 520, we'll say. And now that's going to be nanometers for the wavelength. So one's being measured in meters, one's being measured in nanometers.